All right, so graphing a function with a specific domain produces a discrete graph. What's your second blank? All right, so what is a discrete graph? Okay, Brandon, what's a discrete graph?
That does not line up.
Not
You
true.
can't have in between numbers on it.
So it's just dots, right?
Yes.
Okay, so they are not connected. So a discrete graph is not connected.
Yes.
Okay, so if you were given specific domain, what would specific domain be? Like specific x values, okay? If you're given specific x values, then you will have a discrete graph, is basically what that sentence is saying. Okay, so when we look at example 1, it says graph each function for the given domain. The function given to us is y equals 1/2 x plus 3. And then the domain, that's what the little d right there represents. The domain is -4, -2, 0, and 2. So because we have these values that were given to graph for the domain, that's going to make it a discrete graph. So we're only going to have dots, nothing else. Okay, no lines to connect them or anything like that. So what you're going to do is make yourself a table with x and y and domain values. Yes, ma'am.
Brandon Barton needs to leave school, please.
Okay, I'll send him up. Okay, so you're going to put your domain values here. So -4, -2, 0, and 2 are domain values, so they go under your x. Then you're going to go to your calculator and go to y equals. And type in your function, which was 1/2 x plus 3. Okay, and then you're going to go to your table, which is second graph. And you're going to look for where x equals -4, so I need to scroll up. Okay, so when x equals -4, the y value is 1. Okay, and when x is -2, what is the y value? 2. And when x is 0, the y value is 3. And when x is 2, y is 4. Okay, so now that I've got those numbers, we're going to let them act as ordered pairs, and we're going to put those points on the graph. So the first one you want to graph is -4, 1. So 1, 2, 3, 4, 1. Be right there. Okay, the next one you want to graph is -2, 2. So right there. Oops, I got mine off a little bit. Let me try that again. I have to make my graph bigger. I can't see it. Okay, so the second one we want to graph is -2, 2. Okay, the third one we want to graph is 0, 3. And then the last one we want to graph is 2, 4. Okay, so when I refer back to this original sentence we have, the original sentence says, graphing a function with a specific domain produces a discrete graph. So we were given a specific domain, right? Like we had domain values that we were given. So that means that we're going to have a discrete graph. So because of that, I will not connect those points. I'll just leave it like that. Does that make sense? This is yes. This is no. Yes, no? Okay, good. All right. So then it says, what is y when x is 6? So if I look at, if I look at my graph, when x is 6, my y value is also 6. So to answer this question, when y is 6, x is also 6. Okay, so let's look at example 2. Actually, let me do this so I have more room. Yes, sir.
When is your graph?
Do you have MAFS?
Yes, I think so. You get 2 every 6 weeks.
Mm-hmm. Okay, hold on, bring me my seating chart up there. Okay, so on example 2, we have f of x equals this. So what is that little thing right there, the x with the lines around it? Oh, actually, it's under my keys right there. It's kind of like, do you remember what it's called, though? Starts with the A. Anybody remember what that's called? Absolute value. Okay, so we're going to be looking for the absolute value function. So to enter that in our calculators, we're going to go to y equals, clear out what we've got there. And to get the absolute value function, here's what you do. You push math, arrow over to number, and it's the option number 1 that says abs. It's not talking about your stomach, it stands for absolute value. So push enter. Okay, so we want the absolute value of x. So you just type an x in there and then arrow out and you're done. Okay, and then on this one, we are given specific domain values. So here's our domain values that we're given. So in our table, we still are going to do x and y, and we're given -2, -1, 0, 1, 2. Okay, so then when I go to my table in my calculator, I can see that when x is -2, y is +2. And when x is -1, what is the y value? 1. Okay, when x is 0, y is 0. When x is 1, y is 1. And when x is 2, y is 2. Okay, so then I put that on the graph. So x is -2, +2, which will be right there. Then when x is -1, y is +1, so I go right there. When x is 0, y is 0, so at the origin, and then 1, 1, and 2, 2. Okay, so should I connect my dots or not? No. I should not connect them because what? But why is it discrete? Yeah, because it gave us these specific points right here. It's discrete, so we just put dots on our graph. Okay, so the question down here says, what is f of x when x equals -2? Is that a -2 or +2? Okay, so it would be 2 then, right? So 2 is my answer. Okay, so on the back, here's your blanks that you need to fill in. It says graphing a function with an infinite domain produces a continuous graph. So what is infinite domain? Okay, first, what's infinite? Forever. So that means you can use any number, right? If it's infinite, it's because it's all numbers. And what is domain? X. Okay, so it's saying you can use any number you want to for x because it's infinite domain. And it produces a continuous. So what is a continuous graph? Where you connect the dots. So if you can use any number that you want to for x, then you should connect the dots. That's what that's saying. Okay, so let's look at example 3. On example 3, it says y equals 2x plus 1. It wants us to graph the line y equals 2x plus 1. But notice on this, it's different from our other 2 examples because we are not given specific numbers to use for x. So you get to pick whatever you want. I would recommend always choosing the numbers from -3 to +3. So if it doesn't specify, then you should do like this. -3, -2, -1, 0, 1, 2, 3. So if it doesn't give you numbers, those are the ones that you should choose. And then to get your y values, you're just going to put the function in your calculator and see what the y values are. Okay, so for my y values, I'm going to go to my calculator and put in y equals and type 2x plus 1. Go to my table. So when x equals -3, y equals -5. And when x equals -2, y equals -3. When x equals -1, y equals -1. When x equals 0, y equals 1. When x is 1, is +3. When x is 2, y is 5. And then when x is 3, y is 7. So I'm going to graph all those points. So -3, -5 goes right there. -2, -3, -1, -1, 0, 1, 1, 3, 2, 5, and 3, 7. Okay, so on this one, should we leave them dots or should we connect them? Okay, why are we going to connect them? Yeah, the domain is infinite. It didn't give us specific values. We chose some specific values just so that we could figure out what to get on the graph, but we can have any number that we wanted to. So to show that, we're going to connect the dots like this and put arrows on the end of the line to show that it keeps going forever in both directions. All right, then for example 4, we have f of x equals x squared. And on that one, let's see, hold on, let me get my graph. Okay, once again, it doesn't give us specific values, so when it doesn't give you specific numbers, what is a good idea to use? Good, from -3 to +3. So we'll go -3, -2, -1, 0, 1, 2, 3. Okay, and I'll go to y equals and type in my function, which is x squared. And then go to my table. So I can see when x is -3, y is 9. So I write that down. And when x is -2, y is 4. When x is -1, y is +1. When x is 0, y is 0. When x is 1, y is 1. And then 4 and 9. So I'm going to plot all those ordered pairs. So I have -3, 9, and then -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Okay, so this one doesn't make a line, it makes kind of a U, right? So we just connect our dots right here to make our U shape. And we have a question right there that says, what is x when f of x equals 9? So it wants to know the value of x when f of x is 9. So where could I look to find that? What? In your calculator? Okay, so what do I look for there? It'd be both of them, right? So on this one, when y is 9, whoops. When y is 9, the x value is -3 and +3. So there's two answers there. So you should put -3 and +3 for your answer. Okay, And that's it. Now, your homework tonight, I believe there are 7 graphs. So you should be able to fit 7 graphs on one piece of graph paper, but if you need some, I have some you can have.